So hi everyone, and thank you very much for attending this brief ST conference. Today we'll deal with the usage of STM32WL for smart facilities application. So of course I thank the Things Industries for organizing this special edition of the Things conference. Let's start straight away with some market data about commercial buildings. Of course, commercial buildings represent only a subset of all the small facilities that will be dealt with in the framework of this conference. However, it's already a good way to have orders of magnitude about expected shipments and growth, for example. So if we focus on the three segments where we expect the biggest volumes, we have in a third position the lighting with smart lighting, light controllers, light switches, for example. In a second position, we have HVAC, standing for heating, ventilation and air conditioning, where we could have, for example, terminals and chillers, thermostats, air handling units, or also whatever air controllers. And in the first position, we actually have what is mentioned here as other sensors devices, which actually encompasses a lot of different kind of sensors, such as occupancy sensors, motion sensors, temperature sensors. And also it's also worth mentioning that the current COVID crisis is actually boosting the expected volumes for cleanliness management and hygiene management, obviously. So the expected volumes are there and the trends are there. So how could we serve all these kind of different systems and devices with STM32 microcontrollers? Let's remind the portfolio of STM32s currently on the market. So we have four different kind of segments, or four different segments, depending on the internal architecture of the microcontroller, such as ultra-low power microcontroller, mainstream MCUs, or high-performance ones. And of course, we have the wireless microcontrollers with STM32WB for 2.4 GHz communication, meaning Bluetooth, Zigbee, or Thread, for example. And of course, here we focus on STM32WL, targeting long-range communication in a sub-gigahertz way. STM32WL is currently the only system on chip in the world merging both the ultra-low power architecture of a microcontroller along with a LoRa-enabled multimodulation radio. On top of this, we actually added another core, an ARM Cortex-M0+, bringing advanced and additional security features. So let's see what kind of examples or systems are used with STM32WL by different kind of companies and different kind of ST's customers. Let's start with NB-IoT, which is a Polish company using STM32WL for gas, water, and heating systems. So NB-IoT are able to leverage many different kind of STM32WL benefits. The first one is the ultra-low power aspect of the chip. Indeed, in stop-to mode, the STM32WL is able to reach down to 1 microamp current consumption. And so the system can constantly switch in between stop-to mode and run mode. In run mode, the order of magnitude of the current consumption is about 71 microamp per megahertz. So it's up to you to run the clock of your MCUs and the radio at the frequency that you want, from 0 up to 48 megahertz. So using interrupts and switching from stop-to mode up to run mode, you can manage your application in a very smart way. And actually the wake-up time in between the stop-to mode and the run mode is extremely aggressive, because it can reach down to 2 microseconds or 5 microseconds. Another feature used on the STM32WL is the dual power output. Indeed, there are two power outputs, one which can go up to 15 dBm, for example, for the European market, and another one which can go up to 22 dBm. So in that case, NB-IoT used the 22 dBm power output. Also, they used the LoRaWAN stack that is actually currently available on st.com free of charge in the embedded software package called STM32WL software package. Okay, you can find this stack online, and it has been certified for all the regulatory regions as defined by the LoRa Alliance. The package that is currently used by NB-IoT in such gas, water and heating system is the QFN one, which means that the PCB is actually kind of cost optimized. Indeed, QFN is the cheapest package in the portfolio that of STM32WL packages that I will present just after. And the hardware is actually compatible with Sigfox here. So talking about packages and PCB optimization, we have indeed two different kinds of packages with STM32WL. QFN 7x7 that can be used for cost optimization because you can enable 2-layer PCBs. And there's also BGA package 5x5. So the footprint is tinier and the full applicative potential of the chip can be leveraged because up to 43 GPIOs can be enabled. In both cases, 3 different sizes of flash are available, and there are 2 versions of the chip. One which is dual core with ARM Cortex-M4 and ARM Cortex-M0+, and another one which is single core with ARM Cortex-M4 only. So another very cool example comes from the Italian company Engineco, using STM32WL for different kind of application as well in the framework of smart facilities. So the black one on the left side is actually a level detection, very useful to make your management of facilities in a smarter way, because you can, for example, detect the water level in case of flooding, the level of snow outside, or even the level of waste in a trash can in a smart waste framework, for example. The one at the center is an environmental sensor, able to monitor the temperature, the humidity, the pressure, also the luminosity, and even the CO2 level, and thus the air quality. And this is actually super cool because here it's a merge of 2 different kind of technologies, because obviously LoRaWAN is used to communicate in a long range way, but also you can power it on and off through NFC technology, so short range technology versus long range. And there's also a super cool firmware over the air update over NFC, which is achieved in that device. The third one is the very basis of a smart building, because it's a smart plug, always very handy and useful. So if we focus on the environmental sensor, here obviously the ultra-low power aspect of the STM32WL is used, but also the BGA package is used here because many GPIOs can be leveraged. Indeed, you need to connect and route all your sensors around the STM32WL to different kind of GPIOs, and the other remaining GPIOs can be used for whatever other reasons on the PCB. So the footprints in all these, the footprint of the PCB in all these cases is quite small thanks to the BGA package as well. Here again, the hardware is able to support Sigfox. So let's take the opportunity to remind the flexible power scheme of STM32WL. So I will remind here that the RF part of the radio part of the device is always available in all the modes except shutdown. So for example, that means that if your device is in standby mode, that means that the MCU part of the device is somehow asleep, but the radio part of the device is still able to transmit or receive a LoRaWAN frame on a LoRaWAN network. RAM retention, same story, always available in all the modes except shutdown, very handy to keep your applicative context. And regarding the set of peripherals and wake-up sources, actually from stop one mode up to run mode, all the peripherals and wake-up sources can be used, whereas in stop 2 mode, you are able to reach down to 1 microamp current consumption, while still being able to use quite a wide array of peripherals and wake-up sources. Let's switch to another example coming from another Italian company called Enerbrain. So here the model is somehow kind of different because here the device is actually already connected to a public LoRaWAN network and at the same time on a Sigfox network. So it's a great example here of a device leveraging the multi-protocol capability of the STM32WL. Of course, the STM32WL here is also used through its ultra-low power aspect, many GPIOs, etc. But there is also a web app from Enerbrain that makes you able to manage your connectivity, LoRaWAN connectivity or Sigfox connectivity in an easy way and manage your fleet of devices. And talking about multi-protocol capability, let's remind that there are 4 different kinds of modulation available in the STM32WL. The first one is LoRa modulation, and with LoRa modulation you can address LoRaWAN protocol, but also LoRa-based proprietary protocols. And with the 3 remaining modulation, which are GFSK, GMSK, and BPSK, you are able to address other protocols, such as Sigfox, for example, wireless M-Bus, or Zeta, currently growing in China and Japan, for example, and of course, many proprietary protocols. And on a daily basis, we face customers using, for example, LoRaWAN as the main protocol and another proprietary protocol along LoRaWAN. Of course, impossible to have such a keynote without mentioning the Things Industry's generic node that will be able to be used for whatever development, even in a smart facilities context. And let's remind that at the very center of this device, there is the STM32WL chip as well, used because there are many GPIOs available that can be connected to all the sensors on the generic node. So a very expected node, development node and reference design, which will come very soon. So the key points about STM32WL are the following ones. Of course, it's a multi-modulation and multi-protocol capable device. It comes with a massive integration because it's a system on chip, which leads to massive cost savings on the customer's side. The platform is dual core and fully open, so it will always be up to device makers to decide whatever they want to flash inside the product and whatever protocol they want to implement inside it. It's a ultra low power because it's based on STM32L4 architecture. It comes with advanced security features thanks to the dual core architecture, and it's thus ready for the IoT. The offer of packages and part number is quite wide, 2 different kind of packages, 3 different sizes, single core or dual core. The ecosystem coming with it is very rich, and we will come back to this later on. And there's a 10-year longevity commitment. So today we focus on the I would say smart facilities, so smart buildings and smart cities, and we highlighted some features that can be leveraged in this framework, such as the 22 dBm output power, the robust RF link, or the reduced bill of material cost. But actually STM32WL can also be used for all the other vertical markets, such as utilities with the linear frequency range, industrial IoTs with IoT application with a very aggressive wake-up time, unique IDs for traceabilities, or battery lifetime optimization for a smart home, for example. So what are your tools to start your smart facility application development? First of all, let's remind the ecosystem coming with STM32WL. In terms of configuration, you are able to use STM32CubeMX, which is extremely useful when you want to configure the pinout of your chip to generate the clock tree synthesis, for example. But above all, with STM32CubeMX, you will be able to generate some code automatically, which is very useful when you want to prototype your device in a fast way. In terms of IDE, there is STM32Cube IDE, which also comes free of charge. All the tools from STM32Cube ecosystem are actually available on STM.com free of charge. So with STM32Cube IDE, you are able to start your development with the GCC toolchains. There are also partner IDEs such as IAR Systems or ARM Kyle. With STM32Cube Programmer, you are able to flash your device, and with STM32Cube Monitor, you will be able to perform RF advanced testing, such as testing your modulations, testing the LoRaWAN AT commands, for example. Last but not least, in the embedded software package called STM32WL, you will find the LoRaWAN stack certified for all the regions, and the Sigfox stack also certified for all the regions. All of this comes free of charge. In terms of hardware ecosystem, of course, most of you know the STM32WL Nucleo development boards, which has been used as the LoRaWAN certification vehicle, so two different part numbers depending on the region that you want to address. Of course, we know today that it's quite hard to get some, because the demand is huge and the worldwide situation does not help. So we are doing our best to replenish our stocks, and some more Nucleo boards will be available on the distribution website very soon. So now I would like to highlight two very important points for your development around STM32WL. The first one is the documentations that comes with STM32WL. Whenever you want to start developing with STM32WL, either with the Nucleo board, the Cube WL, or the Cube IDE that I just mentioned, you will find on st.com very user-friendly documentation around this. And actually, some of our customers ask us to switch from STM32L0 to WL, or to STM32L4 to STM32WL. And for this reason, in case you need it, there's a migration guide for this. Now, in terms of protocols, it's not necessarily easy to start a LoRaWAN application. So that's why we created some special guide called How to Build a LoRa Application that will help you in this purpose. Also, you have documentation such as the LoRaWAN AT command, or even some documentation about firmware update over the air. And by the way, in the LoRaWAN stack available in the STM32WL embedded software package, there are some examples about firmware update over the air. Now, in terms of hardware development, maybe the hardest part of hardware development comes with the RF part of it. So that's why we created two very handy documentation for this purpose. First of all, with a documentation specialized in the matching network creation, where you can find the de-embedded impedance, for example. So it gets easier and easier for you guys and ladies to create your RF application, hardware application, and also some guidance around RF board layout. Now, a critical part of your system development is also the certification, and so that's why you will find some documentation where we explain what we did in ST to certify the Nucleo boards. So that's a very good example to see what we did in ST for this, and we also provide some guidance about what to do on your side to certify your device. Now, another very important point, and the last point that I want to highlight in this keynote, is the availability of a reference design on STM32WL. Website. So in case you are not already aware, if you go to st.com/STM32WL in the tab called CAD resources, and you find hardware design models, okay, it's not so easy to find maybe, you will find many information about a reference design, such as the layout, the schematic, the bill of materials, the design files. So I really want to remind that, because that means that you can take it all, copy paste in your application, add whatever sensors around it for dedicated to your application, and it will be very easy for you to create some STM32WL based system. Okay, so please enjoy it, and you will have a nice confidence level about your ability to reach certification. So I thank you all very much for your attendance. Of course, if you want to have a more deeper presentation about the STM32WL, you can find different videos on YouTube. The first one is a 1-hour presentation about the STM32WL product, or you can even look at the replay of the last keynote from the Things conference held in January. So let's talk in few minutes on Whereby, where we'll have a Q&A session. I hope to see you in the real life very soon. Thank you very much again for your attention. Bye bye.